We often talk about things other than area and volume. When it comes to solids, there are several things that are related to the volume. Some of these items include a capacity. Capacity is like the number of cookies that fit into this cookie jar versus that cookie jar, or the number of loaves that can fit in this oven as compared to this other similar oven. So it's the number of something. Sometimes we talk about weight. How many pounds does this box weigh, and how many pounds does a similar box weigh? How many ounces of cereal will fit in this box versus how many ounces of cereal will fit in that family size box? Weight is related to volume, and also mass, like kilograms and grams. These are also related to volume. So you can use the volume ratio when any of these concepts appear in a problem. So let's try it. Wilmington, Delaware is trying to break the world record for the largest pumpkin pie. To do so, they have constructed a pie pan with a diameter of 10.5 feet. It is similar to a standard 10-inch pie pan. If a standard pumpkin pie weighs about 2 pounds, how much will Wilmington's pie weigh? So we're going to go through the same 4 steps that we went through in our previous video. So the first step is to write and identify a ratio with the given information. Once again, we want units to reduce out, but I'm not seeing anything with the same units. I'm seeing feet and inches and pounds. But wait a minute. Feet and inches are both measures of distance, and we can convert feet to inches. So let's do that really quick. 10.5 feet, there's 12 inches in 1 foot, so we can get rid of those feet there, and that turns out to be 126 inches. So 10.5 feet is 126 inches, and now we have a ratio that we can write. We have 126 inches over 10 inches. And of course, if we reduce that, divide top and bottom by 2, and reduce out the inches, we end up with 63/5. So that is our ratio. What ratio is that? Well, those are lengths, aren't they? So that is a length ratio. So we've written our ratio, we know what it is. Now let's move on to the next step, write the scale factor. Whoa, wait a minute. Remember similar figures? The scale factor and the length ratio are exactly the same thing. So we don't need to do any work to find the scale factor when we have a length ratio. That's cool. Step 3. Let's write the needed ratio. Notice that our problem is asking us for weight. We don't have a weight ratio. Oh, weight! Weight is related to volume. So we can use the volume ratio. So let's turn that scale factor into a volume ratio by cubing both the top and the bottom. This is going to get big. 63 cubed happens to be 250,047. And 5 cubed is 125. Fortunately, we have calculators to do step 4. We're going to write a proportion and solve. We are going to use the ratio that we just wrote in step 3. And our proportion is going to involve that 2 pounds, right? So notice how the 2 pounds is aligned with the 125. The small pies are aligned across the bottom. And the weight of Wilmington, Delaware's pie is across the top with the 25,047. You know what? This is set up so nicely to undo division there on the left-hand side. All that we have to do is multiply both sides of the equation by 2 pounds and simplify. The weight of the Wilmington pie is going to be 4,752 thousandths pounds. So how much will Wilmington's pie weigh? About 4,000 pounds. And by the way, go ahead and do some research. You'll find that if Wilmington, Delaware does do this pie, they will have the world record for the heaviest pie, but not necessarily the largest, because the largest pie actually has a diameter of about 20 feet. Look it up. Capacity, weight, and mass are all related to volume, so when you're asked to find something about that, use the volume ratio.